Hello everyone, we will continue working on the network topology. In the last lesson, we created a PCI VPN topology using TLC. Today we will operate by specifying the next hop and adjusting the VPN membership. There are two methods in total. The model we need to operate on is still hub and spoke. From BR2 to BR1 is a direct communication that requires indirect communication, passing through the DC as a basic operational step. First, we need to check our current environment, then implement the policy. Once the policy is activated, we will conduct ping or trusted tests. Alright, let's start with hub. And spoke, we will do it now. We will complete the core VPN by filtering. Let's take a look at our policy. I have already implemented this policy. Specifically, what policies have I implemented? First, let's look at the direction of the policy. When BR, our two branch offices, send out routes, what do we do? Let's look at the policy. Edit it. Our condition is when BR sends out routes, we take an action on our vSmart piece. Note that this action is to deny. What does it mean? We prevent direct route exchanges between BR1 and BR2. Block it. Besides this, the routes between BR1 and DC and the routes between BR2 and DC need to be allowed. This point is important to note and easy to overlook. Now, we will activate this policy. Activating the policy. This policy is being sent. The policy is distributed via vSmart to CH devices. CH devices will then filter each other's routes. Please wait a moment. The policy is currently being applied. The policy push is complete. Let's observe the routes. I prefer using the command line. Let's directly observe on the command line. The VPN 10 we operated on just now is gone. The network of VPN 10 is 192.168, and the 20 network is no longer present here. If there are no routes, it means communication is interrupted. Let's trace it. Going to destination 20, VPN 10, to re-emphasize our topology. If the topology is relatively large and you are not familiar with it, it's suggested to print it out, as we mentioned earlier. Select the interface, start again. We find that the result is a trace failure. What's the reason? We already observed in the command line that there are no routes. Okay, the usual practice, our expected observation point is from the CH side being allowed. Can we guide our traffic to DC1? Absolutely possible. What's the general method? The most common is to release a default route to our BR1 and BR2 so that traffic can go through DC. How to do it? Use templates. Let's go back to our templates. Do you remember how we were working with our templates? We created them based on a combination of site and platform into our templates here. Here we have templates for DC1 and for DC2. Actually, what we need to operate is the DC1 template. Within the DC1 template, we mentioned earlier, the VPN we intend to operate on is the COP VPN, which is identified as number 10. Alright, let's go. I found this VPN 10. Here is a VPN 10. You can see we're giving it a default route. An IPv4 default route. Note the next hop here from the perspective of DC. Looking at the next hop, if I set the next hop to null, it means that when the other side receives this default route, it will come back. This is set to null. Let's update it. VPN 10. Some parameters have not been activated. I need to enable the null feature. Next step, we update our configuration to prepare for root pushing. This step is generating configuration. We need to wait here. Successfully back to the command line. You can see the default route has arrived, right? Let's try translate again. Okay. Now from router 4, BR2 going to BR1, first reaching 20.1. Where is 20.1? Is our DC 20.1. Then it reaches 20.3 via the MPLS line. Okay, this error is now resolved. Up to this point, we've completed the operation through route filtering for the COP VPN. Next, we'll adjust the VPN membership. This scenario still involves looking at the topology. Let's observe the site we're preparing to operate is DC2. Why mention VPN membership? We notice that DC2 has both COP and VPN services. BR1 and BR2 both have the same services. We specifically removed the PCI VPN from DC2. At this point, we hope to control DC2 through VPN membership to prevent it from receiving routes for VPN 2.0. This is our intention. Before proceeding, we need to revoke the previous policy. Revoke. This is the previous policy. We will revoke it. Next, we create a new policy for VPN membership. Alright, before creating the policy, let's first observe the steps we need to take. We need to check the current environment, then implement the policy. Let's look at the current environment. I have already revoked the previous policy. In the current environment, we are observing DC2, Sedge 6, observing its routing scenario. In the monitor menu, we see the routes received by OM without filtering. We observe it has received many routes, including VPN receiving IDs. VPN 10 is fine. It also has VPN 20, can you see? VPN 20's routes are not what we expected to receive. For DC2, it doesn't have this service. I don't want to receive these routes. Alright, we will filter this route. Adding a policy. Next, we will work on VPN membership. So here, we switch to VPN membership. Adding a policy, creating a new one, naming it for DC2, specifically for DC2's VPN. We select the site. For the site, see edge, how many VPNs we have. 2. For DC, we can abbreviate. For BR, representing 2 sites, with PCI and those 2. But for DC2, it only has core. It's very straightforward. Through this membership list, we have isolated DC2's VPN. No problem. We can directly proceed to the next step. There are no other policies. Name it. This is our membership list. Let's activate this policy. During the configuration process, we can click on the device number, the device's UE. Then, let's take a look. This type of configuration and the previous one. What new additions were made? We can see the list of policies called VPN 10, the PCI label number, label 20. This is very clear. And make sure to review after class. Here, pushing the policy successfully validated our policy. We need to verify device number 6. We hope to see its routing filtered, which routes, OMP routes, in which direction it received them. We observe VPN without filtering 10. There are no more routes for 20. Similarly, switching to the command line for DC2, we find the VRF routes cleared, because we didn't compare before, but the routes for VPN 10 are still preserved. This advantage is very clear. Multiple VRFs for one site. We can operate them independently, without affecting each other. Having this feature is very important in our wired network environment. If you expect to test a new service, we can separate test projects from production projects with VRF. See, so the test environment won't affect the production environment, enhancing work efficiency. Alright, let's look at our slides again. We've implemented 3 very important control plane policies and completed them through the use of templates. The first one is PCI VPN. We achieved hub and spoke through the TLOC method. In COP VPN, we use route filtering to filter specific routes between sites to implement COP VPN. The third strategy is through the VPN membership list. We can isolate a specific device's VPN, for example, the PCI VPN just now, through the VPN list. We exclude its membership achieving root filtering. Alright, this concludes today's lesson.